Assalamualaikum and hello. We are going to continue with the mechanism of electrophilic addition of alkene with hydrogen halides. In this mechanism, actually we just taking out from one of the chemical reactions of alkene in the previous video, which is this one, hydrogen halides. So we are going to explain and describe the mechanism how alkene reacts with hydrogen halides to form haloalkene. The introduction that you have to understand is the name of this reaction will be hydrohalogenation. And for the type of reaction, only one type of reaction for alkene, which is electrophilic addition. And the last one, you are going to use your reagent, which is only hydrogen halides. Your hydrogen halides can be as general as in HS, and it can be either HBr or HCl. X here means either bromine or chlorine. Now we are going to learn how this mechanism happen for alkene with hydrogen halides. When writing down the mechanism, you have to write the chemical equation first because there will be 1 mark for that. So I'm going to write my mechanism as general. For example, I take ethene. This is my alkene. I got ethene reacts with HS, produce my haloalkene. I'm going to put whichever side that I want because both of them contains the same number of hydrogen. But if you got another alkene with much more longer carbon chain, you have to follow the Markovnikov's rule when determining which position for X and H atom will be attached to. So for the step number 1, once you write down the chemical equation, you will get 1 mark for this one. And now we are going to do the mechanism for the step 1 where you are going to form the carbocation. So how to form the carbocation? We got alkene here and reacts with HS. Open the bond between H and S. Now you can see that H is electropositive atom and X is much more electronegative. So I'm going to put partial positive here and here partial negative. So when you do the reaction mechanism, this bond contains 2 electrons and will be transferred to more electronegative atom, which is X atom. And this double bond from alkene contains high density of electron, so it will attack hydrogen, which is more electropositive. So the bond here in your alkene will break down where one of your carbon involved between this double bond will has positive charge here. If I put the numbering, this is carbon number 1 and 2. This is number 1, number 2. So right now, carbon number 1 will contain positive charge because less electron, and carbon number 2 will take hydrogen from here. So you got extra hydrogen atom here. And what's next? You detach. X will be X minus. So X minus means you got more electron here. So X minus will attack carbon that contain positive charge. This is carbocation. So carbocation here will be attacked by X minus. So you have to show the mechanism using full-headed arrow. And this reaction is very fast. And what happens next? You will attach X to your first carbon and hydrogen to the second carbon. So this is the mechanism for alkene with hydrogen halides. And make sure you show the reaction for the first pathway in slow and the second pathway in fast. So what I put here, you have to follow and write it down as it is in your answer. Let's try one example for you to understand about this mechanism. So I need you to outline the mechanism of propene with hydrogen bromide. So I got propene with 3 carbon atoms, 1, 2, and then 3. I'm going to give the numbering. So this is 1, 2, and 3, and the double bond between carbon number 1 and 2. And the rest of them, I'm going to put hydrogen. If you cannot see the structure very clear, you can expand your structure or just expand the atoms for the carbon involved. So the carbons involved in this reaction is between carbon 1 and carbon 2. So from here, this alkene, my propene, reacts with HBr to form my haloalkane. I got H plus and Br minus. So H plus will be added to carbon with more hydrogen atoms attached to it. So between carbon 1 and carbon 2, this carbon-carbon double bond, carbon 1 contains more hydrogen atoms. So I'm going to attach H at carbon number 1 and my halogen at carbon number 2. So this is where I follow Markovnikov's rule. So my product will be H bonded to C, and you got H, single bond C, and then you got CH3. So for the numbering, you got this one carbon 1, carbon 2, carbon 3. So carbon number 2 will attach to Br and carbon number 1 will attach to hydrogen. So this is my product and my chemical equation. So right now I'm going to show you how to do the mechanism for this one. So mechanism must be in one straight line for this step. It's different from free radical substitution. You got different steps, but right now you have to put in one line. So the first step, you are going to form the carbocation. So copy back your alkene. So this is my alkene. Reacts with HBr. Open the bond between H and Br. So you know that H is electropositive, so partial positive for H and partial negative for Br. And here I'm going to use my alkene attack from double bond to hydrogen. Use full-headed arrow. It means that you move 2 electrons here. And here from this bond to the electronegative atom Br. My product will be H2C, and I got single bond C, and then H, and then CH3 plus Br minus. And in this case, I'm going to determine which carbon will contain H plus. I got this one as 1, 2, 3. And here I got 1, 2, 3. So the reaction happens between carbon 1 and 2. So from here, you can see that hydrogen attached to carbon number 1. So you got extra hydrogen here at carbon number 1. And now my positive charge will be at carbon number 2. So this is my carbocation. So right now, I'm going to use my Br minus, my anion here, and attack my carbocation at carbon number 2. So from here, I'm going to attack like this one, from the charge to carbon. And what's next? My reaction, I will form haloalkane where I got H3 carbon with C, and I got Br, and I got CH3, and I got H. So this is my haloalkane. And my reaction, please don't forget, you have to put slow and fast. So this is going to be slow and this is going to be fast. So this is the mechanism for propene when reacts with HBr. So I hope you are clear, especially for the part that you determine the positive charge on the carbon, because we are going to form the carbocation first. So that's all for this video. I hope you are clear with the mechanism of alkenes with hydrogen halides. That's all from me. Thanks for watching. Bye.